So species is something that we say a lot. It's kind of common vernacular, but we need to talk about the biological definition of a species. So we're going to look at an example first. So I think you're all fairly familiar with the case of the donkey, and if you cross a donkey with a horse, and specifically if you take a female horse and a male donkey, what you get is you get a hybrid that is a mule. And since we're in Texas, you've probably all seen horses and donkeys and mules. There's some benefits to doing this hybridization. If you're a farmer, you end up with a mule which is stronger than a donkey and tends to have better endurance than a horse. And so they're fairly desirable work animals for farms. The problem is that when you take a mule and you cross it by another mule, what you get is no baby mule, because mules are sterile. So mules are not considered their own species, and we consider a donkey and a horse separate species because when you take a mule and you cross it to another mule, it doesn't make any baby mules. And so here's the biological definition of a species. A species is a group of organisms that can produce viable, fertile offspring. And viable means living, and fertile means can reproduce. Now, when we're talking about biological species, we typically are talking about a group of organisms that can produce viable, fertile offspring in nature. You've all heard of ligers or tyons, and so a tiger and a lion can reproduce and produce an offspring, and those offspring are actually capable of having offspring of their own. What you see in that situation is you see a very high rate of cancer in the first generation of hybrids and the second generation of hybrids, so they actually have reduced viability. But that would never happen in nature because lions and tigers don't actually live in the same area. They're separated, they're geographically isolated species. So what we're talking about is organisms that are not reproductively isolated in space or time. So they actually have the opportunity to reproduce with one another. And when they do attempt that, they cannot make any offspring, or if they do make offspring, their offspring are not viable. And we're going to talk about the mechanisms for that in class. It's one of our quads. So let's talk speciation. So there's two forms of speciation, two main categories of speciation that you are going to need to know as far as I'm concerned. And there's really four categories, but they're really just subdivisions of the two categories I'm going to show you. So the first category is called allopatric. Allopatric speciation occurs when a population becomes geographically isolated. So you end up with some barrier. So I'm going to have my bunnies, right? I've got my population of bunnies. And then I'm going to have a river flow through my population of bunnies. So now, if in the southern population of bunnies, which is geographically isolated from the northern population of bunnies, if a mutation arose through random chance and made the bunnies in the southern population have an allele for brown, one of two things could happen. That allele could spread or it could not spread. We're going to assume that allele spreads. So if that allele spreads and we end up with brown bunnies south of the river and white bunnies north of the river, there's a chance that what I've had happen is speciation. And it doesn't have to be a phenotypic change. It could actually be something, or not a morphological phenotypic change. It could be a molecular change. But I wanted to give you something that was visually easy to see. So if we actually took those bunnies, the brown bunnies and the white bunnies, and we put them back together, the creek dried up, the river dried up, and the populations came back together. If we found that those species were no longer capable of reproducing viable, fertile offspring, then we would say that the northern and the southern populations have formed two different species. So that would be an example of speciation. But the only way to actually know that is to see if they're capable of reproducing. Typically, after lots and lots and lots of generations, you get mating behavior where organisms don't even recognize one another as potential mates anymore. So when we talk fireflies, there's different blinking patterns. Birds, there's different courtship songs or courtship dances. So the second form, that's geographically isolated. It's got a river, right? The second form is going to be not geographically isolated. And so that's going to be called sympatric. And it occurs when populations, when a new species evolves within a population without geographical isolation. So there's no geographical isolation. This is actually a little tougher to wrap your brain around. And I'm going to give you some plant examples. But first we're going to start with our normal bunny, right? And then what I'm going to have is I'm going to have a subset. I'm going to have somewhere in the population, I'm going to have some new mutation arise. And for some reason, that mutation is going to persist and it's not going to be spread throughout the population evenly. Because if the mutation arises in that one area and it's bunnies, you would think, oh, it's going to spread out. Maybe there's some sexual selection. Maybe brown bunnies only want to mate with other brown bunnies. If that's the case, what would happen is that you would have the brown bunnies always reproducing with organisms that already carry that mutation. So sexual selection could lead to this. There's some other things. In plants, it's really easy to have this happen because in plants, it's very common to have polyploidy, which is basically a doubling or a tripling or a quadrupling of the chromosome number. So let's say I've got a plant that normally has 13 pairs of chromosomes, and one generation during meiosis it doesn't happen correctly, and suddenly I end up with an offspring that has 26 pairs of chromosomes or 39 pairs of chromosomes. That would be an example of immediate speciation. As long as those organisms are capable, as long as those plants are capable of reproducing, you could see how that would immediately give rise to a new species. But with animals, it's a little tougher to wrap your brain around. So normally, when we talk about this, you really do have to think about a long time, because what you tend to have is you have like a hybrid zone around where the brown bunnies would be mating with some of the white bunnies. But as long as there's some reason that the hybrids are not as fit. So the rock pocket mice is a good example. If you took a black rock pocket mouse and a sand-colored rock pocket mouse and they made an intermediate phenotype, then that would be an example. That's not how it actually happens in rock pocket mice, but you could foresee how that would happen there. So you would see that over time, what's going to happen here is you're going to end up with the white bunnies still, but now you're going to establish in that center area an overlapping population that is not capable of breeding and producing viable, fertile offspring with the parent population. So we would consider that speciation. So those are really the only two forms of speciation I want to talk about. We are going to talk about the ways that we can categorize reproductive isolation beyond geographic barriers and beyond like courtship ritual behavior. So we're going to talk about that in class. If you have any questions, just come on in and see me or send me an email.